Okay, so let's talk a little bit about history of computer science. Computer science compared to physics or mathematics is relatively young discipline. Even though there are lots of algorithms that are attributed to mathematicians in 19th centuries or earlier, we could kind of pinpoint or date the start of this as a separate discipline to around 50s. And what happened around 50s was that lots of universities started to offer some kind of a computer degree to the students, and of course that was separate than mathematics degree. So before that time, people who would work in computers, they would think of themselves as engineers or mathematicians or stuff like that. But around that time, the word of a computer scientist or a discipline that is dedicated to various aspects of computation was started. And if you look at lots of fundamental algorithms that we learn today in any undergrad degree in computer science, lots of these algorithms started back in the day. So you have, let's say, merge sort that started in 45, was developed by John von Neumann, and etc. By this time, we are very nicely settled in how we do computer science, especially when it comes to theory of computer science. So if you've taken, I'm sure you've all taken the algorithm and data structure course, and over there you look at an algorithm and you analyze it, you prove correctness, you use O notation and stuff. So for example, if somebody gives you a quicksort algorithm, so something like this, and also before going further, we write algorithms using pseudocode. Back in the day, people would use flowcharts or even codes to display algorithms, and the concept of pseudocode did not exist, and people just thought of algorithms as like a program that you write. And having a pseudocode is actually a little bit of a mental step. And given this pseudocode, we analyze these algorithms. We say that, for example, the partition part of a quicksort runs in linear time of O of n time when n is the number of elements in the array. And then we also could say that quicksort runs in n squared time in the worst case, but it runs in n log n time in the expected case, or if the array is shuffled randomly. If we pick the pivot randomly, then it runs in O of n log n expected case. And all of these things we can prove using mathematics. So in a nutshell, we are using O notation. We have some underlying assumptions such that all the instructions over here that I display by the pseudocode, except for the for loops, they run in constant time. So like if you want to do this if statement takes constant time, if you want to increment variable I takes constant time, swapping takes constant time, etc. And that's how we do algorithms today. But it wasn't always like this.